Okay, perfect. This is where we left off last time. Last time, obviously, we were still talking about variables. And the last thing I talked about was constants, which are variables that we follow a convention with that, if you follow that convention, has a special meaning. It means this variable can be assigned once, but then leave it alone. Never change its value. You can access it, you can use it in calculations all you want, but you never change it. And the way a programmer knows it's a constant is because it's all uppercase and separated with underscores. That tells another programmer it's a constant. It means leave me alone. There's nothing actually stopping another programmer from changing that value, but they would be committing a pretty bad sin. So they just don't do it. Other programming languages, if you define a constant, might actually prevent you from actually making a change. The program wouldn't run. Python, it'll run. It's just you're a bad person if you change the constant. And the value of constants are, well, it signifies, okay, here's a value, leave it alone. It gives you a nice way to name an important value, like in this case we used for 1.15, we said sales tax. Oh, okay, that's what that means, right? And finally, I mean, it's a variable. If I was using that calculation in a billion locations in my code, and they change what the sales tax is, I got to go and update my code everywhere. Well, no, now all I have to do is update it in one spot where that constant is, and I'm all set. And that's where we left off there. So any questions about that? Variables are constants, before we move on to the next topic. Okay. Oops. Cool. All right, statements and expressions. I mean, we've seen already, everything was in Colab, but programs are made up of series of lines of code. You can have a program that's one line long, but usually you have a lot more than just one line of code. And each line does some amount of work or computation. I mean, a single line can do a lot, really, but we try not to do too much in one line. And so each of those lines of code, like each thing we have, is a statement. It's an instruction for Python to do something. And if you type a series of statements and press run, Python does exactly what you asked. Whether you really wanted it to do exactly what you said is another thing. But it does exactly what you said, or at least it tries to. It might crash and burn. Maybe because you did something wrong or there was an issue with the logic, who knows. But something could go wrong. But sometimes statements have an immediate output, an immediate effect, like the print, right? Print hello world. Well, that displays something. That's output. All right? But a lot of other statements do things behind the scenes where it's not obvious of what it's done. It's changed the state of something, changed the value of some variable, for example, but it doesn't produce an output for you to confirm it at that stage, and that's fine. So sometimes statements have immediate output, and sometimes it does something, but we can't see what it's done immediately. We might have to print that value out if we updated the variable. I'll show you what I mean. If I said a equals 5 and then b equals a times 2, right? Both of those lines of code, they did something. There's no output here. I don't see anything, but they did something. So based on this, if I were to say, if I wanted to know what the value of b is, well, I can print it out, and I see that it's 10. Why? Well, a became 5, and then a, 5 times 2 is 10. Store that in b, print out b, we see 10. Cool. So an expression is a special type of statement where some number crunching happens. It doesn't necessarily need to be numbers, but some evaluation gets calculated. So here's some examples. So it's something that gets crunched to a value. More precisely, expression is a combination. Yeah, an expression is going to be a combination of statements, literal values, variables, and operators. Like this right here is an expression that takes the variable a, multiplies it by the literal 2, and stores it into b. The nuance of the difference between the word statement and expression is not overly important. People mix them up all the time. but I'm just telling you now so you have a clear idea. And then operators. Well, we've been using operators in our code already. That's something like plus, minus, multiplication, and division. So as a quick activity, there's actually two activities, but first I'm going to have you do this first one. If you blitz through the first one and you get it done, great. Move on to the next one, okay? To write some code to convert a temperature from Celsius to Fahrenheit. If you're struggling through the first one, that's fine. I'm going to go over it before I get to the next one. But I'm going to give you a few minutes to try to work through these activities to just see if you can get things going for you. Raise your hand if you're done the first activity. Raise your hand if you will be in like 30 seconds. Cool, okay. Now, if you were working through the first activity and it was a little unclear, the instructions were a little vague, so it's fine if you did things a little differently. It's fine. The point isn't that you do exactly what I had in mind. It's that you did something at least similar-ish, and you were playing with variables and making expressions that got evaluated. So here's what I did. I created the four variables, actually, A, B, C, and D, and I gave them arbitrary values. Doesn't really matter. I just assigned them values. The first step was add two variables together and save the result in some variable. All right, so I added A and B together and saved them in a variable called sum of variables. Cool. The next step was multiply two variables together and save the result to some other variable. All right, so I'm assuming I meant to multiply two other variables together. If you did the same variables, it's fine, it doesn't matter. But I took C and D and multiplied them together and saved it in the variable multiplication of variables. Great. Then I say divide the result of step 2 by the result of step 1. Okay, so divide multiplication by the sum, and then add a third variable to the result of step 3. Well, I just added D to the result. And when I run it, that's what I get. Cool. 10. Cool. If you prefer doing it in another step, that's perfectly fine. Equals multiplication divided by sum. Nope. And then there. You might like this a little more, but it's functionally the same thing. It does the exact same thing. I just kind of rearranged where the number crunching happened. So any questions about that? Yes?
Why does the division return a float value instead?
It's a good question. It's because it's just always going to do floating point division by default, for better or worse. If you really wanted it to be an integer, we do that. It's the same thing. This right here is actually something, I believe I talked about it briefly in lab the other day. When they made Python version 3, they actually changed that feature where the division would automatically turn something into a float. And that pissed a lot of people off, myself included. I don't really like that it does that, but by default now, division will give you the float just in case. And if you want integer division, which every other language is going to do by default if you're dividing integers, you have to do the special operator divide. That's all. But you're right to observe, like, we were dealing with integers and a float came up. Yeah, I know, it's weird. Python's annoying like that. Some people love it. Usually the people that hate it are experienced programmers who know that this is unlike everything else they've been doing for decades. That's all. Other questions about what we just saw here? I want to stress again, if you did it a little differently, fine. If you only use two variables and you use that's fine. It doesn't really matter. What matters is that we're playing around with values variables, making expressions, and seeing what the results are. Now for the tougher one. Raise your hand if you finished this. Cool. Raise your hand if you haven't started it yet. Cool. So I want you to start it. But raise your hand if you know offhand how to convert Celsius to Fahrenheit. 2 people, 3 people, 4 people. Don't worry, neither do I. But you know who does know? Google. So you go like this. I gave you a link, but if I ever ask you to do something that you don't know how to do, look it up. There's really no secret to it other than, like, I don't know, ask Google. If you came to me and said, yeah, but I don't know how to convert Celsius to Fahrenheit, I'm going to say, neither do I. Figure it out. And look, there it is. You take the value in Celsius, multiply it by 9/5, and then add 32. There you go. Cool. So figure out how to convert a temperature from Celsius to Fahrenheit. And to give yourself a little bit of a, use a variable. And then, I don't know if I'm spelling that right. Do a calculation for Fahrenheit, and then, this is wrong now, clear. And then print So see if you can figure out how to do the calculation. Give you a minute or so to try this out. Raise your hand if you're done. Raise your hand if you'll be done in like 30 seconds. For those of you that are done, you can compare yours to mine. Did anyone do theirs wildly different than mine? What'd you do? You used the input? Cool. Anyone else use the input? Yeah. But if you use the input, did you convert it to an integer? Good stuff. Because if you do input, what type is the input always going to be? String. Exactly. Very good. So you got to be careful with that. Now, I will say something about input, and I'm about to talk about input in this topic too, don't get me wrong, and I know we used it in the lab, but primarily for this course, with the exception of like this topic and labs, we don't use input. Feel free to, right? But we're not typically going to use input. Like if you're working on an assignment and you find yourself typing in input, unless it's assignment 3 where I explicitly tell you to do input, don't use input. It's going to give you trouble. So we don't typically use input, but there's nothing wrong with using input. So if you didn't use input, that's absolutely fine as well. So here's how I did it. I just hard-coded the value for Celsius. I did the calculation. Where did I get the calculation from? From Google, because I didn't memorize that. And there we go. Celsius times 9/5 plus 32. Cool. Did anyone calculate 9/5 and put in the decimal value there instead? That would work if you wanted. Also here, the parentheses aren't necessary. The order of operations would have been followed, but the point of code is to be as clear as possible, and I feel as if adding the parentheses around the Celsius times 9/5 helps make things a little bit more clear. Even though it would function the same, the code is about clarity, not just functionality. I feel like the parentheses help make it a little bit more clear myself, so that's why I did it that way. And then once I do the calculation, I print out the result. At any point, I didn't really need to use variables here. I could have just plugged all these numbers into an expression and I could have immediately printed it out. That would have been fine too. It doesn't really matter, but I did it this way because I think each line is nice and clear and succinct. I don't know, I really like it this way. Any questions about how I did it, why I did it this way, or anything else? Okay, yes? How to turn it into an integer? Well, it is an integer. Oh, well, that would be tricky. What we could do is just say this. You could wrap it in int, which would then just turn it into an integer. But the problem isn't necessarily the right word. The problem with doing it this way is with a float, if you have a number that's a floating point number and it has decimals, and you convert it to an integer, all of the decimals are deleted. It doesn't round. If you have the number 1.999999999999999 and you convert it to an int, the answer is going to be 1. And you're going to say, but what about the 0.9? It's gone. That's what happens when you convert it to an integer. So if you really wanted to round, you might need to look into rounding it. That would work too. If you decided that maybe this would be the way to do it, is like, okay, well, it only turned into a float because of the division, we'll do that. Well, we got to be careful because the 9/5, when I do 9/5, let's see, 20? 68. And what happens if it's like that? 60, 21? I got to find a number where, yeah. So 69, 69. So it looks like it's kind of working, but I'd be cautious of this because 9 divided by 5 9 divided by 5 is 1.8, but 9 divided by is 1. So you got to be careful with something like this. I'm guessing it might even be because of this. 53 versus 69, yeah. So it's just because it just happened to do the 9 divide times the Celsius and then the division. But anyways, does that kind of answer your question, how to convert the float to the int? Cool. Other questions? Is that a question or a stretch? Stretch, okay. All right. Sure the camera's still working. Oh, it's not. Let's see if we can fix it. Let's change. Let's try that real quick. There we go, we're back. Yesterday's the camera froze like 2 minutes in, and so the whole lecture it's a video of this. It's great. All right, so there we go. If you were stuck with that, there's a video here to show you how to do it. I will warn you, some of these videos, you'll kind of get a sense of which ones are which. Some are recordings of lectures, they're just recordings of lectures. Some of these videos I made years ago, and they used Python 2. And there are a couple of small differences with Python 2, one of which will be that division, which I probably talk about here. Ah, see, look at that. The 1.8 and then the 9/5. I got a different number. What's going on? Because division is different there. So be warned of that. And another thing, too, is in Python 2, you do print a little bit different. Instead of print parentheses, you don't have the parentheses in Python 2. So if you're wondering why my prints look different in these videos, it's because it's actually a different version of Python. Other than that, it's basically the same. There are some other differences that might come up later in the course, but they aren't that big of a deal. All right, operators on other types. Well, there are operators for values other than just numbers. Okay, this one, I'll just work through it here. So look, if I said print hello plus 8, that doesn't work, right? I mean, it doesn't even make sense to ask. But what do you think is going to happen if I do this? Oops, not that, like that. Does that really make sense? Well, I don't know, it's in the eye of the beholder. Apparently Python thinks so. So it turns out multiplication is defined for an integer, or sorry, for a string, but what did it do? Hold on. Let me perhaps make it a little easier. There. What did it do? Well, it just repeated the string 3 times. Now, obviously, before seeing this, you wouldn't have known that. But the creators of Python, they thought, yeah, this is a good idea, so you can do this. Then you might say, well, so someone had to say multiplication on a string did something, but no one said addition on the string would do anything? Yeah, I guess not. I guess they didn't do it because, honestly, I still don't really know what that means. Multiplying a string by 3? Yeah, sure, I guess that kind of makes sense in terms of functionality. Now, I'm curious if the order matters. Can I do 3 times hello? 3 times hello? Oh, looks like it works just fine. So if multiplication worked, can division work? Well, no, it's not going to work. Can subtraction work? No, it doesn't work, no. So I guess some of them work, some of them don't. And the only way you're going to learn this stuff is by trying and doing. What happens if you add strings together? Well, we saw that already. We saw that already. You just concatenate the strings. You just stick them together. So addition works on strings, but it works differently than with numbers. With numbers, the plus sign means sum. The plus sign with strings means concatenate. So it has different functionality depending on how it's used. Try mixing strings and integers. What happened? Well, I spoiled it for you already. So larger series of statements. Everything we've written so far has been very few lines of code. But they're lines of code, right? And if I want to run multiple lines of code, well, I just write multiple lines of code and I hit run, and Python will run all of those lines of code in order that it goes, starting at the beginning and going to the end. Now, sometimes we can write code where it's going to jump around a little bit. We're going to do a lot of that. But it really does follow a very clear deterministic path. You start on one side, you work your way through until it's done. So we often write very large pieces of code. Often, we also aren't writing code in things like Colab. There's nothing wrong with Colab. But if I'm writing code for a really big project, I'm going to use something called an IDE, an Integrated Development Environment, which is a tool that has a lot of bells and whistles that makes my job as a programmer a little bit easier. And if you really wanted, you can start using an IDE for this course. I don't recommend it because they tend to be a little overwhelming, and all the tools and bells and whistles that they have to help you aren't really going to help you at this stage. If anything, they're just going to distract you and overwhelm you. But if you're taking 162 next semester, which I will always say I highly recommend, it's way better than this course, and I think this course is great. But next semester, we are using a different programming language, and we will be using an IDE. But at this stage, we're not going to get the ones with all the bells and whistles, but we're going to have files full of code that we're going to run, maybe sometimes multiple files filled with code that we run for a single project. That's very typical. In Colab, you'll notice that the cells, like everything's persistent here. If I say a equals 5, and I hit run, and then down here I said print a, it's going to work. It's going to work even though they're in different cells. It's fine because currently Python is aware that a is equal to 5. Interestingly though, if I go here and I delete this, a's gone, right? And I hit run, well, it shouldn't know what to do. Well, it does know what to do. Why? Because it still remembers, well, you did say a was 5, and I remember that a was 5. If you really want to obliterate everything that you've written in code, even if you've deleted it here and you can't see it, but you still wrote it and ran it, you have to go to like runtime, restart session. It won't delete your code, but it'll forget everything that you told it before. So now if I hit run, it's going to say, what the hell is A? I don't know what A is. Cool. What else should I say about this? This right here can be the cause of some confusion for new programmers with how the notebook-style programming works, but it shouldn't be too bad. I'm trying to think. There was something else here I wanted to say, but I can't quite remember. If you like to write all your code in the same block, cool. If you like to use different blocks of code on Colab, that's entirely fine. Doesn't really matter. It's up to you. Use the tool how you like. Any questions about this? Yeah.
What IDE do you use
Next semester, we're going to use IntelliJ. Yeah, IntelliJ, JetBrains. And if you were to ask what IDE should you use if you really wanted to use one for this course instead of Colab, I would say use PyCharm. PyCharm and IntelliJ are basically exactly the same thing, just one's for Python and one's for Java. Why? Which one do you have experience with?
I've used a little bit of VS Code.
Okay, yeah. Yeah, okay. VS Code's nice. It's very lightweight compared to the other ones, which is usually pretty good for new programmers, actually. It's really nice. Yeah. So far, yeah. And whenever we save something from Python, it's saved as a script. We call them scripts. The programs for a language like Python, they're scripts. If I have like a bunch of code, 55, 44, b equals 7, print b, print hello, right? If I run this, great, cool. If I really wanted to download this code as a script, I can. But everyone watch for a second because this is very important. All of the files that we want, we can go file download. But you'll notice that there's two options. There is a IPYNB and then a .py. If I ever tell you, give me the script, it's the .py file. .py, .py, .py. That is your normal Python file. The .ipynb, I'm pretty sure that means IPython notebook. That is to save it in a format like Colab. On your assignments, when I say give me your script, if you send me the .ipynb, you get a 0 because you didn't submit your script. And I've seen every game where, oops, I submitted the wrong file. But here's the right file, but it's late. Well, that sucks. Submit the correct file, follow the instructions. If you mess up, like don't mess up. It's hard to mess up. You'll be okay. Just do what I say. It's described in the assignments. If I were to click this, file, download, let me show you what I mean. File, I'm going to download both versions. Okay? Untitled, untitled, untitled. So if I were to open this, I'm just going to open it with like Notepad. Oh, come on, Notepad. Just a regular old boring text editor. This is what the IPython notebook file looks like, which is crazy. This is not helpful. I can't do anything with this. This, when it's read into something like Colab, Colab knows how to decode this. That's great. If I wanted to open up the actual Python file, this one, open with Notepad. Well, it's got this comment at the top, but you can quite clearly see it is verbatim, one-to-one, the exact code I wrote into Colab. Yeah. So there it is, it's the same. So I want the .py files, .py for Python. Any questions about that? All right. Okay. So here we go. Here's a quick little activity. Consider the sentence, I am taking CSCI 161, right? There's 1, 2, 3, 4, 5 different like words in there separated by strings. Here are strings. Here's what I want you to do. Write a program that stores each of those words in a sentence on their own. Sorry, in a sentence, in a variable of their own. So each word in that sentence I want to be in a separate variable. But what I want you to do then is figure out how to print the whole sentence as like the makeup of the individual variables that store each individual word. I'll give you a few moments to try that one. This is a good activity. But yeah, the trick is use only a single print. Raise your hand if you're done. Raise your hand if you'll be done in 30 seconds. Okay, take your time. If you did it like this, you kind of cheated, actually. Who did it this way? Yeah, you kind of cheated, actually. And here's why you technically cheated. It's fine that you cheated. I'm not going to rat on you or anything. But the reason you're cheating is really what I want you to do is to print out like one single string. But when you did it this way, we actually did print out 1, 2, 3, 5 separate strings just within a single print line. Really what I want you to do is to create like one string and then print it out. See if you can figure that out. But of course we know how to concatenate strings, right? So yeah, see if you can figure that out. Did anyone do this? And they're wondering, well, like, I'm close, but something's not quite right. It doesn't have the spaces. Does anyone have this currently? No? So the problem here is I'm concatenating all those strings, but I need spaces between them. So how could I add the spaces? Well, the good news is a single space can be a string. Let me show you what I mean. We could do A plus the string space plus B plus the string space plus C plus the string space plus D plus the string space. There we go. Look at that. Who got that? So the trick here was all of the variables stored in an individual string. Oh, wait. Did anyone cheese it by doing this? Who really cheated by doing this? Yeah, you should feel terrible about yourself. You're cheaters. Come on. Gee. You know what, though? Way to think like a good programmer. But not quite really what I wanted. So what did I do here? Well, I took the string that was stored in A, and I concatenated it with the string that happened to be singly, like a single space. And then I concatenated that, and so on, and so on, and so on, and so on. Is that clear? Or does anyone have questions about what I did here? If you have questions, please ask now, because I love answering questions. Yes?
Is there a space in between the quotations and the, okay. Yeah.
Yes, there is. And I could do whatever like that if I wanted. It does exactly what I say. You can put it whatever you want, but yes, there was a single space there, yes. Other questions? Yes? So if you used a comma, it'll work, but you're actually doing something a little different. Functionally, at the end of the day, what we see is the same, but what's different is with the pluses, we're taking all of those individual strings, turning them into one big string with concatenation, and then printing that out. With the commas, what we're doing is we're printing out 5 separate individual strings. The end result looks the same, but really there is a difference. It's fine if you did whatever. It really doesn't matter. These activities at this stage are just to kind of show you the variety of ways to go about doing it. Yeah?
Why do we have to put the quotation marks like after the plus sign and in between?
So they're not really after the plus sign. Really, it's the string stored in A concatenated with the literal string that is a space. Concatenated with the string stored in B, concatenated with the little string. So it's not that the quote is like, oh, why did we need a quote after the plus? Well, really what it was is we needed the quote to create a new string literal that happened to be after the plus. Here's another way we could do it, and this might actually be nice and helpful with your particular question. There. Here. I'm going to change it slightly, and maybe this will be a little clearer, because in here I'm mixing the use of concatenations of variables storing strings and literals of strings. So here, I made a new variable called space, and I just put in the value space, the string space. So instead of including the literals here, I could say space, 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 space. And it works the same. Yeah. Does that clarify?
Yeah.
Okay, cool. There's something else here I wanted to show you, but now I can't remember. Whatever. You could do something called an F string, too. This is something we'll talk about a little later, but I'll show you now because it's kind of cool. F for format, you could do this. Whoop. Which is kind of hard to see what it really means, but it allows you to do like inline like insert variables into a string in line. It's kind of nice, but this is something we'll talk more about later. I'm just showing it to you now because why not? Another interesting thing too to note is in Python, whenever we are printing a value out, if I tell Python to print out the integer 1, Python actually, you say print integer 1. That print function, Python will take that print function and take the integer 1 and go, that's an integer. Let's turn it into a string and then print it out. So everything we see printed out is technically a string. It gets converted to a string, whether it was a string or not. Python will try to convert it to a string before it prints anything out, which is kind of neat. But this idea will come up a lot more near the end of the semester, where we explicitly describe how to turn things into strings. But I'm getting way ahead of myself. I'm just telling you so you have more ideas as we go. Yeah, there we go. Cool. Cool. I feel like there was something about this else I wanted to hit, but I can't quite remember what it was. Well, whatever. Any other questions? Yes.
For the example with the green, the comment,
Yes.
using the comma as space?
Well, the comma isn't a space. What it is so I've added all these different strings, and this print function, whenever you add multiple arguments of individual values to print out, it adds, whenever it formats the output, it adds a space. So the comma doesn't mean add a space, it's just that print will add a space for each new value you put in. So one could say, well, so is adding the space for each comma. Yeah, but that's not why, but it's like a coincidence that it lines up, but yeah. Good observation though. Other questions? Again, to be clear, if you did it with the commas, that's fine. If you added the space to the end of each string, yeah, that's fine, right? Good job. You were clever and you solved the problem, right? Cool. Cool. Yeah?
Could you make how do I say this? Could you just make the whole, could you make A, B, C, D, E equal something and then print it and then it would be technically one string or?
I'm not quite sure what you mean. I mean, I can make the variable A, B, C, D, E.
No, that's not what it means. It means when we printed it before, we printed variable, first one, then printed space, It's just asking if you can, instead of putting it in a print function, just define that as a variable, then print that as a variable.
Oh yeah, that's fine. Yeah. It's like you concatenated them and saved that to a variable and then printed out the variable.
So that would count as one print.
Yeah, that's fine.
Okay.
Well,
That's just the same thing.
it is effectively the same thing, yeah. Based on my understanding of what you're asking. Yeah. Cool. All right, the next topic is inputting and changing types. So this we are a little familiar with from lab already. We've seen input and we saw why it's important. We have to be careful with the type. And here's why. Let's say value 1 equals input. Give me a number. Whenever you add text to the input parentheses, it displays it as a prompt. Warning, never do this on Caddis. Caddis will say you're wrong even if you're right. Value 2 equals input. Give me another number. And then print 1 plus value 2. And we all know that, okay, 1 and 1, we all know 1 plus 1 is 11. We all know this. This is obvious, right? Why is it obvious? Because the string 1 plus the string 1 means concatenate the string, so we get 1, 1. But this probably isn't what I wanted, right? Really, I even said, give me a number. Well, it's because input, no matter what, input always reads the input as a string. So if I wanted it to be an integer, I have to go out of my way and say int that and int that. And now if I do 1 and 1, it's fine. But I have to be very careful because if I mess up my types, like imagine I wrote this code, I didn't test it, and I assumed it was right. It seems like it's kind of right in the fact that if I put in two numbers and I got the number 11, I guess the number was the sum was 11, right? I mean, we know it's wrong because we see what's happening here with these simple numbers, but it almost appears like it could be working correctly, and that's very dangerous. So you got to be very careful with the types. And also, by the way, if you enter something in this particular situation and I say convert the string hello into an integer, Python goes, what the hell? I can't do that. That makes no sense. Anyways, we'll pick up here on Friday.